We've got the formal announcement here. So you're very welcome. Tomas O'Leary is my name. I am one of the founding directors of the Passive House Association of Ireland, an organisation I'm very proud to be involved in, and working with a great group of people who are promoting the Passive House standard in Ireland, and also trying to provide as much information as possible in stimulating events like we have this evening. We would love you to check out the PHAI website at some point, and we would love you to join the PHAI if you haven't done so already. Lots of benefits to membership, including access to lots of events behind the wall. And so we're really delighted to have you here this evening. We have a very exciting presentation this evening, which my colleague Simon will be introducing in a moment. I just want to mention the usual housekeeping. It would be wonderful if you could keep muted for this evening until, of course, we open up the mic and we take questions. And we hope there are questions. We have a very, very exciting project tonight. And we're going to prove that Passive House is not only for houses, it's also for non-domestic. I'm especially interested in the project tonight because we were involved in it ourselves for the last several years. So please do check out the PHAI website. And so in terms of the proceedings this evening, my colleague Simon will introduce the speaker tonight, and then we'll have a lovely presentation on the Southwest College project in Enniskillen. Then there will then be we'll have a Q&A. Hopefully you'll have some questions. You can put those in the chat. We then do a thing called a breakout room towards the end, and that's where you get a chance to meet in a more intimate way 2 or 3 other people in the room and just have a chat. Rather than being in a big room like this, we can get to have a discussion about what you learned this evening, and then we'll close it off. So Simon, if I could turn to yourself and maybe you could introduce tonight's speaker.
Thanks, Tomas, and welcome everyone. So tonight we've got Dr. Barry McCarran, who's going to be discussing the new Passive House premium building at Southwest College. I'm sure you've seen it and are as excited as we are to hear about that. It's literally just completed. Barry is the Research and Development Coordinator for Southwest College, based in the Crest Centre, which in itself was an early Passive House non-domestic project in Northern Ireland. And he's coming from a background of a number of international advocacy roles on climate and carbon forums back in his early career, including the Youth Climate Coalition delegation at COP17 in South Africa. He's held a number of roles with architects, with suppliers, manufacturers. He's acted as a BER assessor. So he's had quite a varied background in coming to the position he holds today at SWC, where he's got a varied role in supporting businesses to upskill, to innovate, involved in research and development, and also heavily involved in delivering the Passive House consultants and tradespersons courses at SWC, and in fact was my tutor through that arduous process as well. He's undertaken research on a number of topics, including studies on radon gas in Passive House dwellings, and that was presented at the International Passive House Conference. So he's passionate about Passive House. He's been a board member of PHAI for a number of years and currently holds the chair position in driving this organisation forward at a time when Passive House is high in demand. So before I hand over, I'd just again like to reiterate that if you can pop your questions in the chat. I'm kind of expecting maybe quite a few questions tonight, so I will try and keep on top of that and put some of those to Barry at the end. And if we don't get through them all, we'll get back to everyone after the event. So over to you, Barry.
Thank you, Simon. I'm almost blushing there. That's I think the best introduction I've ever got. So I have a bit to live up to. Thank you, everyone. I think everyone can see my screen. I just want to check a bit paranoid about that.
That's correct.
Yeah, good stuff. Okay, so here we go. Really proud to be presenting the building tonight, and on behalf of the college. There's many other people, and I see some who have joined us tonight who have done an awful lot of work on this project, and I couldn't possibly start to name them all, or I'd be here half the night. Really, really proud to talk about the building. So one of the caveats to just say tonight as well, there is a lot of us from the Passive House community in the room, and we would all love to go down the deep dive and the rabbit hole and talk about all the building physics. But tonight it's a more general audience, so it's a bit of a balance between some of the Passive House numbers and physics, along with some maybe fun facts and that sort of style of presentation. So here we go. So there's our building, as we said, and we're very proud of it. So I'll start on a journey, if you want, to sort of reflect the other presentations we've had in this series from we started it. This is the fourth and last of this series, and we're going to run another one in the autumn winter as well, with maybe more events, maybe 6 at that style. But the early ones, which you can watch back on YouTube via the PHAI website, they were all from people sharing their journeys as well. So I'm trying to reflect that as well. So Southwest College, we're an FE college in Northern Ireland, and we're the largest, and that might be surprising to some. We have 5 campuses which are located in the counties of Tyrone and Fermanagh, so it's really way out west in a sense. The college has an annual budget of about 41 million, give or take. We've about 18,000 enrollments at any given time, and between full-time and part-time, around 900 staff. So we are quite a big organization. And if we look at the map there, what we'll see is that at each campus, we have an innovation center, and that's the particular area in which I head up in the college. And I'll come to it in a wee second. So really the context of tonight's presentation and why we're really all here is that we're under pressure to really adapt to the changing world and the climate change imperative that's upon us. Buildings account for again, some might be initiated in this and others mightn't. But if we were to look at all the carbon that's generated in the world, buildings account for just over 40%. That figure fluctuates depending on the report. But with that in mind, it really is the low-hanging fruit. It really is the nettle that has to be grabbed in order to combat climate change. And when we look at this, the various reports that have been done by the United Nations, you can see that back in 2007, they started to mention Passive House, and Passive House has been in their literature all the way through to today. And we're starting to really see a bit of momentum generating where this has percolated down into the industry, and we're really starting to see a bottom up and top down coming together to really bring Passive House to the fore. So that's it. So yeah, as I said, the journey and in the previous slide with the map of Northern Ireland, the innovation centres. So back in 2015, the college we were in the phase of constructing those innovation centres, and the last one to be plugged onto the system at that time at our Killyheveland Skills Centre was the Crest Centre, which Simon mentioned there in the introduction very kindly. So we went after the Passive House standard for that building. It was part of a capital build with an EU project we had called Crest as well. So that was the first non-domestic Passive House building certified in Northern Ireland. And with that, we had a legacy plan with that building as well, in which we would try and get onto the platform of delivering training and trying to upskill people in Northern Ireland. So since that, we've had modest growth, I'll say, and we've chugged along, and we're starting to see more and more organic interest with people coming to us through word of mouth primarily as well, which means we're doing something right. But at this stage, between the designers course and the tradespersons course, we're up to about 200, maybe even more, closer to 250 now trained. And then side by side with that, we have been involved in a number of different certified projects and a lot of research and development work and mentoring of architects and different industry people who have also come through those courses. So it's been a very, very good journey for us and very positive for the college all round. And really it was, in a sense, the guinea pig for a bigger project, which this building at the bottom shows us the existing campus in Enniskillen, just less than a kilometre away from the Crest Centre, which I just showed. We have 2 campus sites in the town of Enniskillen. And for our international audience, maybe tonight, it also hosted the G7 recently as well. So it very much is on the map as a place. Now, this building, I suppose, is a baseline, and that's what this slide is about. I walked into the building a few years ago to try and get to the bottom of this, and according to the energy label on the building, it's saying here that it's at 152 kilowatt hours per meter squared per year just for the heating alone. And then I went to the caretaker and I asked, well, what's the story with oil and all the rest of it? And we went through it. So depending on the seasonal nature of year on year, the building averages out at about, needing 100,000 litres of oil a year to heat it. And again, oil prices fluctuate, but on average you're talking about 51 to 52,000 pounds a year to run that building, and it's just coming up on 50 years old now, and it's a D-rated building. So really that was the baseline, that was the existing building, and then fortunately we were commissioned a new building on the site of the old hospital in Enniskillen, and here starts the journey then with the Erne campus. So the college took over that site, and there was a lot of demolition that had to be done with the hospital. So for people who might see 2016, that wasn't the complete construction phase. There was a bit of site work that needed to be done beforehand and preparation. And then COVID, of course, delayed things a little bit as well. But really the brief to the architects was that we wanted to be Passive House premium, we wanted to be BREEAM outstanding, and we really wanted to be world-class, both in respect of the standards, but also the teaching and learning facilities inside. So that was really the brief, and really to have a step change from our existing building, which I just shown. So what's interesting about this building, and here are some photographs, and I know not many people have visited the building yet, and we will be having a series of events later on in the year and into next year as hopefully COVID is in the rear view mirror. We'll be able to host many people. But what's very interesting about this project is the mixed use of it. We have hair and beauty, which I'll be in all the time, getting right through to the gym, and then you can see here in these photographs, and you'll see later in other photographs some of the other parts of the building. And what I'm missing here as well is, as part of the school, and one of the main schools in the portfolio of education we have is a catering school. So there's a very modern kitchen and area in the building as well. So we really have a mixed use going on here, which is really very interesting from a Passive House point of view as well, with all the demands. So really in this section now, I'm going to go into a part of the presentation which is really going to reflect the 5 principles. So we'll go through that, and the first of this is really the building fabric, and we can see here some of the cross sections from the BIM model. I've pieced together some of the drawings and highlighted to you the insulation layers, and then out here I've dug out some of the U values and indicative insulation levels of thickness, and of course then as well the proportionate percentage of what the envelope is for each of them. So the floor, again, we're coming in at a U value of 0.25. Again, you're talking about 90 mil insulation there, and 27.8% of the envelope is the floor. And of course, when I'm saying that, I'll say as well, the roof is also 27.8, and we have there as well a U value of 0.15, which is at the Passive House recommendation. And then with the wall, we have a slightly better U value as well. And interestingly, you'll notice that the wall has less a proportion than the other 2 elements. So that's really the first sort of slides on the building envelope. And really, whenever I'm talking about the 5 principles, I put them across in that we have the building envelope first, And I like to say, if you're looking after and adding insulation to the building envelope, it's then really important to deal with the thermal bridging and the junctions of the building. And that's the second slide that I have up here to talk about with respect to this project. So having talked to the guys on site, the team there, Paddy and Donal with Tracy's, what we were really seeing from them and hearing from them was this was one of the areas that was particularly new to them and different about this building as opposed to other projects. So we can see in some of the details here where there is, you know, an intervention in place and the introduction of a thermal break. And again too, here we can see in the structural steel as well, where for the first time as well for that contractor, there was a thermal break provided in the steel structure as well. So that's a little bit of an overview here as well. We can see some of the thermal modeling and the mitigation and the effort and on the calculations and on the building physics side to reduce the heat loss from the thermal bridging. So again, I took a deep dive into the PHPP and pulled out some interesting facts, if you like. So there's 4.5 kilometers of thermal bridge accounted for in the Erne campus building. And about half an hour ago before the talk started, I was trying to look up something relative. What is 4.5 kilometers? Turns out the Port Tunnel in Dublin is exactly 4.5 kilometers long. So for some people, that's a really big visualization of all the thermal bridging. And then when it was all calculated, the psi values were no worse than 0.07 watts per meter Kelvin for the building. So that sort of maybe illustrates quite well what efforts were took to mitigate the effect of thermal bridging. And I suppose on the flip of that, it also makes one think about what goes on in a non-passive house building, perhaps as well, if you have similar lengths of thermal bridging. So the third principle really sometimes is you know, pitched at the windows. So again, in a domestic situation, it would typically be triple glazed windows, and in this, there's quite a lot of glazing on the front of the building, and again with that, we have a whole load of information here, which I'll go through. Again, the different specification for the windows is as follows. We have a G value of 0.41 to throw off some of the heat. The U value of the glazing itself, the glazing now, not the whole window, is 0.53, the frame 0.96. The whole U value of the window installed average across the front of the building is at 0.74, which those in the passive house community would know is quite good. And again, the climate data for this is Belfast Aldergrove, which we had in the last event of the passive house series talking about this. But I'll draw your attention to the energy balance. And one of the things that I think is very interesting, just in a general point, is sometimes to show and illustrate to people how much that so here you have the losses on one side, and I'll not go through every one of them, but you have the floors, the walls, the roof, the ventilation heat loss, and other things in the losses. But here in the yellow, you have the heat loss through the windows at 22.3 kilowatt hours per meter squared. And then if you look over in the gains, also in the yellow, you have the gains from the window. So what's true to say here is that according to the PHPP, which is a very good track record of being correct and right, we have that the windows will provide more heat during the year than they will lose. So therefore, they're in effect a radiator, one could say. So that's a little bit of an overview of the window glazing on the Erne campus as well. And some of the other graphs here I have, again, a little bit of an illustration of northwest, northeast, south and west there as well, of the different elevations, and also a chart for the climate data. So moving on then to the last two principles that would go hand in hand with explaining a building or talking about passive house. That's really you know, air tightness, and you make the building deliberately airtight to a particular level to facilitate mechanical ventilation. So for the Erne campus, and I remember Tomas coming through the door of Hamilton Architects, we were up there for a meeting, and I remember being quite interested to hear about the design stage of the building, and it was spat out at that meeting that we would go for 0.3 air changes rather than 0.6. And I did at that time. I know a little bit more now, but I remember turning my head quite sharply going, 0.3, right? Okay, this is ambitious. But then it became apparent, and many might know in the room as well, the larger the building, sometimes the easier it is to make airtight because of the favorable surface to volume ratio there. So again, 0.3 was the target, and the contractors did very well. They achieved 0.36 overall in the final PHPP. And again, if you see and pick up on the photographs there with a keen eye, you'll notice that, you know, we have a timber frame skin, if you like, on the parts that are not windows, and you'll see that because it's timber frame, it's a tape and membrane approach to the air tightness, and it has obviously worked quite well with that level of air tightness achieved. So this is probably the hardest slide to explain, and also to resist the temptation to go into more detail. But between this and the next slide and the one after, I'll try and make it comprehensive, and maybe we can pick up some questions between me and Tomas afterwards. So really, I'll start at the start. We have a very, so first of all, let me say the ventilation strategy for the building is mixed mode, and it employs both mechanical with a little bit of natural ventilation at play as well in the atrium. So I'll talk you through it. First and foremost, we're taking in air and we're pulling it down into the ground. And we have a huge subsoil heat exchange system here, which is quite innovative and very interesting in combination with passive house for a building of this nature. Very, very common in domestic passive houses in Europe, but not so much here in the UK and in Ireland. So the next slide is talking about that in more detail. So I'll come to that when I get to it. So we're pulling all into a real big mixing box to begin with. And then as we go here, we've two air handling units, two really big, large air handling units that are up on about 87% efficiency with a thermal wheel heat exchanger. And then down, so this one here serves the big rooms, such as the central hall that you would have seen there in that auditorium space. And then the other is a preface, and it serves individual rooms that have individual heat recovery units as well, in the various classrooms, if you like. And then seeing the last part of the whole strategy is really that we use the atrium then as a bit of a dump for exhaust air, with purge ventilation that's controlled by the BMS system as well, which is really the brains of it in some degree, some sense. So it's a very, very interesting ventilation system, and I think, you know, there's a hunger on our half in the college anyway to deliberately maybe, you know, run an event in particular on that later on in the year and talk more specifically about it. So hopefully that's a good sort of general introduction to it without going into real depth detail. So then looking at the subsoil heat exchange, what's interesting here is, again, of course, the drawing. The little fact at the top is quite interesting as well. There's over 1 kilometer of ducting in the ground, and the whole idea here is to, in the summertime, to provide a bit of cooling as the air is coming to being drawn into the building. We know that if we go down a couple of feet into the ground, the temperatures are quite stable there, and cool in the summertime. So if we're pulling air, you know, from outside and it's quite warm, like on a day like today in the height of the summer, we're giving a bit of cooling to the building as it comes in. And then the reverse happens in the winter, where we've maybe cold air outside and then we pull it down into the ground, and then we can take some of that heat from the ground and preheat the air before it gets to the heat exchanger. And all the time, this is helping with the efficiency of the system. So that's really the last slide there, just gone past, of the 5 principles. And then I'll move on into some of the technology space here and talk about some of the heating and a few other bits that are very interesting. So the heating system, the heating system is very interesting. It's a bio oil fueled micro CHP unit. So for a building of this size, CHP can be typically used, but it would normally be diesel. So in this case, we have that, and it's producing 80% of the space heating demand with 100% of the domestic hot water demand. So I suppose the hot water demand in this building is significant with the mixed uses that I talked about earlier on, like hair and beauty, and the the cooking as well, the catering school and stuff like that as well. And of course the gym is there as well, so there's showering facilities and stuff there as well. So with the hot water demand being met 100% by the CHP unit. And then the remaining 20% of the space heating demand is in underfloor heating in sections of the atrium and other spaces as well, and that's an air to water heat pump as well, providing that into the mix for the heating. So that's the heating and the radiators. So some people are wondering about the emitters. So of course the air to water heat pump is an underfloor heating array, and then the CHP is the emission of heat there is through low water content radiators in various locations throughout the building as well. And we look forward to welcoming you and showing you around the building as well in due course. So really moving on then, we're looking at the renewable energy application that's also attached to this building. For those in the Passive House community, you might notice we have this hashtag efficiency first, or efficiency is the first renewable. And that slogan actually originated with the PHEI putting that forward. And with that, it really is a good slogan in the sense that in a way you've no real business putting renewable energy onto a building if the building isn't energy efficient in the first place. And I think that's a real secret sauce for me, or from my point of view. And in this building, of course, we're really happy to have exactly that in play. So to go for premium and to reach that, we have to have this micro generation on site, and we do have it here in the shape of a photovoltaic system, which is quite large, something in the region of 520 kilowatt P, and again a renewable energy figure just below the 120 kilowatt hours per meter squared per year. And again, for those that aren't really that familiar with these systems and what those numbers might mean, you know, the PV is the equivalent to 14 tennis courts on the roof of the building, which is another fun fact. And you can see in the photographs below a lovely shot of the townscape and the mountain Kulka in the background with the PV there as well. So a really good illustration of that energy of first, or efficiency being the first renewable. And then in this chart as well, some can see this later on in the recording if you want to take a closer look at it, but we can see January to December across the bottom with the yield in kilowatt hours here across the side. There's a number of different systems on different inverters across that array, so you can see them all in the bottom in the different colors. And then of course we can see in the bigger bell curve the total generation for all of the different strings there as well. So in the summertime and around this time of the year, you know, the system will generate right up there on 60,000 kilowatt hours. So I mean, really good generation of the system. Here again we have the primary energy or the PER chart from the PHPP, just showing where we come in with premium, and also we took some shots here of the system that we have in terms of energy storage. So there's a particular amount of battery storage in the building as well. So that's a lithium battery storage unit from Tesvolt, and we're at a 460 kilowatt hour or 180 kilowatt hour peak battery storage system there as well to provide short-term storage. So that's really the battery storage system. And then here's a lovely panoramic shot of the building as well, just very recently as well. And that sort of again is a nice illustration of the site and the town, and of course the renewable energy system that's there. So for those of us who are into the numbers, and again we will have probably a more technical talk later on, but there are the Phpp metrics for the building as well. So again, with the air tightness, if you round it up, we're coming in at 0.4. The thermal energy demand is coming in at 8 kilowatt hours per meter squared per annum. The thermal energy load you're coming in, or the heating load, you're coming in at, that should be 9 watts. The primary energy demand, again, 42 kilowatt hours there. Primary energy renewable, as I said, 28.4, and then the primary energy renewable generation coming in at 116, and all of that comes together to make the building Passive House premium. So there's some other things that I wanted to touch on here which are a bit outside of the fold normally. I think it's good to talk about the overheating across the staff in the college. there has been a bit of talk, you know, about the potential for the building to overheat, and I suppose this slide is put in to help you know, show what has been calculated and simulated here for the building. So the overheating, according to the PHPP, comes in at 2.6, and again, that complies with the absolute best practice when it comes to this. Of course, passive house has a threshold of 10%, but this is coming in under the best practice guide of 5%. And again, you'll see there in the last bit of writing I have on this slide, you know, that means that we're going to be less than 228 hours, where we could possibly go over 25. So I mean, if you compare that to normal building stock of this nature, that's quite a bit lower when it comes to the overheating potential as well. So that's good that that's all been calculated and assessed. Another thing that's interesting about the building and all passive house buildings, as the science is evolving with the pandemic, is that you know, the standards itself is going to probably be very good in mitigating against the potential for COVID spread. Now, my own PhD was in the area of indoor air quality, albeit it wasn't with the subject of radon. So if you forgive me for a few minutes, I'll just give you a bit of an overview on this. So if we look here at the categories of indoor air on the chart on the side, not the fried egg diagram I have here. So if we look at the chart, we'll see that there's different categories, 1, 2, 3, and 4 of indoor air classification. And then how that's calculated, you will see, if you can see my mouse, it says here, you know, the CO2 levels in parts per million, it runs accordingly with these different standards. So for 1, you have to be less than 400 CO2 parts per million. The second category is between 400 and 600, which is really, really good. And then you've got the third one, which is 600 to 1,000. And then anything above 1,000 CO2 parts per million is really considered low indoor air quality. And then also with that, you'll see the amount of air supplied that you would need to be in those thresholds as well. So passive house, again, I'll not go too far down the road here, but passive house, you know, sizes the supply air at roughly 30 cubes per person per hour. And that means that you come in between 600 and 1,000 CO2 parts per million. So when that comes into the realm of COVID, you know, CO2 has been found in a lot of the emerging research as a proxy for the potential of COVID to be in the air. So again, if you were in a space that was well above 1,000 CO2, it's probably safe to assume that you would be at a higher risk of potential COVID spread. When you go down the list here into the 600, 1,000, it's much better as well. And because it's a mechanically controlled building, this can be almost guaranteed. Just a note on the other 2 indoor air qualities that are specified here, 400 to 600, that means you need to supply air at about 36 to 54 cubes per person per hour. That's not really that sustainable because the air is forced at that point, and it makes the building too dry as well. And then indoor air quality 2, just a wee note on the climate change about the CO2 levels. The outdoor air of the world, quite soberingly now, doesn't even meet this first category anymore, because we're above globally. We're about 415 CO2 parts per million, so we don't even have that outside now. So looking at the fried egg chart here, you'll just notice again along the bottom, we've you know, starting there at about 16 degrees, we start to come into this less comfortable space all the way to the overheating threshold of about 25 to 26 degrees. So you can see that that's that point right in the center, which corresponds with 70 to 30% relative humidity, is right bang where the passive house standard aims to achieve. And we can see down here where respiratory diseases, bacteria, viruses can lie, and on the other side mold and dust mites and other things. So again, the science is all there. on that. So moving on, other interesting things again, which will probably generate a bit of discussion. Again, let me caveat this by saying this is an indicative figure. It includes the whole site works as well, but the whole project, and again, it's quite a crude calculation, but the whole project was just less than the 30 million. And if you divide that over the treated floor area, you come out at a figure of about £3,500 per metre squared. And again, this, you know, to the best of my knowledge, is a figure that is quite comparable, particularly when you consider some of the buildings being built in the south of Ireland as well to standards, you know. So that's a slide on the project costs. And then in terms of our predicted performance, again, I have to sort of caveat this and say that we, you know, these are rudimentary calculations, but they do give a good picture and an insight into what the standard is going to give to the college going forward. So again, if you remember back to my early slide and my baseline talk around our existing Fairview campus building, which we moved out of now and into the Erne campus, I was saying to you it was around 51,000, 52,000 a year to run that on 1,000 litres of oil. So now if we take the new figure from the final PHPP at 8.4 kilowatt hours, and we just very crudely assume a price just to get a figure of 10 cents per kilowatt hour, you know, which isn't a real figure to a degree, we come out then with, you know, a total indicative cost of heating for the building at around £6,000. And again, if we do the rudimentary calculation there between the running cost and that's a saving of about, you know, 44,000, or, you know, just nearly up on 90% savings for the college on a year-on-year basis. And if you extrapolate that out, you know, and again, there's things that I've left out, you know, like the increase in the price of oil and different things. It's quite safe to say that over the 25-year period, the operational energy cost savings are going to be, you know, over $1 million quite easily. And again, that's just 25 years. If you were to go to a larger lifespan, the savings are even more. So quite a contrast there in performance, and the predicted performance looks very good. So again, just to surmise then and sort of come to a conclusion, we really have, you know, the building is so important to the region, and we're already seeing, you know, just even the noise about the project coming to fruition. We're starting to see and get interest from other stakeholders in Northern Ireland approaching us and asking us, you know, well, how's it gone? How have you done it? And, you know, this interest is really organically coming to us all the time. It is the first Passive House premium project in the UK, and we're very, very proud of that, as I said. And again, it's a lovely demonstration of the application of the Passive House standard in the UK and Northern Ireland. And because our South West College and the Crest Centre and all the rest are offering this Passive House training, and particularly we're trying to develop a bit of a retrofit offering as well for the year ahead. You know, there's no reason why we can't break down any perceived barriers to go into these high performance standards. And again, it really is, you know, in terms of punching above your weight, for us being a regional FE college and from, you know, little old Northern Ireland, you know, it really is world-class excellence and a really good international demonstration for how to, you know, successfully implement things like NZEB or near zero energy as an approach. And again, I've already talked about the energy efficiency being the first renewable as well. So it's a really good illustration of how to achieve that. So I suppose it would be remiss of me not to have a number of photographs, and that's what I have here, a couple of scaled back ones. So again, there's a panoramic shot of the building looking out into the rural hinterland, if you like, at the back. One of the things that I picked up from being up there at the building is just that it was quite a mature site already, where the hospital did stand, and that's really helped the building look even better than a new building would anyway, because it has all of that greenery there as well. One thing, if you can see my mouse, you'll see that there's an old workhouse here at the back, part of the college car park, and we're entering into a partnership here with the local council to develop that building as well. So there's more to come even as well with respect to the site that is the Erne campus. Again, I think we might have seen this earlier. That was to illustrate the PV and again the proximity to the town. And there's another lovely shot looking out at Loch Erne in the distance as well, and the rural nature of the village of, or the town of Enniskillen, and it really is quite impressive. And there's another shot looking the other way back into the town as well. And again, we're on the waterfront, as you can see. And then more interestingly, here's some lovely shots. When we're talking about the architecture, it has this lovely curved atrium that runs inside, and it acts as a bit of a buffer for the accommodation rooms towards the north side of the building. So it really is, when you're inside, astonishing, and very, very you know, a real perspective when you're inside it. Very, 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 very good. And you can see that there's some of these extended balconies with different seating and stuff, having different overhangs and different parts as you go along the curve. And the curve starts with 1 story all the way down to 4 stories as well. So everywhere you stand in it, you've got a different perspective. Here's some more shots of the same, just looking back and around. There's another one showing we've a coffee dock and all at the bottom, but again, sort of gives it a sense of what it's like. There's one from the coffee dock looking back. Again, we have these lovely breakout teaching areas as well, integrated into the architecture of the building, or the circulation spaces as well, which is quite interesting in its own right. Be interested to see how that works. And again, just more photographs to help you understand the scale of the building inside. Again, we hope to welcome you to this room in particular for an event, followed by a tour in due course. So just to round out, one of the things that has really happened with the management, and I have to salute the management of the college with, is really that we want to have a real cultural shift. And with the climate change imperative, the college has took on this one planet living ethos, and we really have a real vibrant team, and indeed the staff have really embraced this so far, when it comes to the whole area of this framework that we're going to bring from September forward, and it really is a staff bottom-up approach to it. So we have a number of things happening internally where we're going to get rid of, you know, plastic bottles for water, right through to having, you know, recycled shops, you know, maybe social entrepreneurship, growing food outside, maybe, you know, bee things on the roof and everything as well. Really exciting time going forward. So the official opening of the college is going to be in September 21. We have really grand plans as well to maybe host an international summer school as well, maybe in conjunction with some of the leading people here in Ireland, and invite people to us. No better place to learn than in a building of this scale. We will have a program of events being out. We've a couple of things in the pipeline with other actors, like potentially the Royal Society of Ulster Architects, the Chartered Institute of Architectural Technologists, and hopefully many others. And if there is people here on the in the call, please come forward, and if you want to host an event with us and get a tour, we'd be more than happy to do it. Of course, COP26 is in Glasgow. The UK is holding the presidency of that conference. So with that, you know, we're going to run an event around that. We have the International Passive House Open Days later on in November. Simon's project this year participated in the Passive House 7-day challenge, where you knock off all the heating and you monitor what the building does during 7 days of no heating, and post it to the world to show them how well it works. We want to participate in that as well. So there's a good calendar of events for the year ahead. It would be again remiss of me not to talk about the team who have been involved. In particular, on the college side, I said the senior management have done serious work on this, along with the team that have worked on the building as well, and the Department of the Economy for sponsoring it and putting forward. Hamilton Architects and Malarkey Pedersen worked really well in that team. You have Tracy Brothers, who are the main contractor. Again, the consultants, we can see them there, structural engineer, and of course Tomas with Mossart, who certified the building. And just This day last month, I think it was, we had again the head of our board of governors and the director of the college and Tomas there to present the certification of the building, along with the then First Minister and the Minister for the Economy of Northern Ireland as well. And again, we now have the tagline of the largest passive house premium educational building in the world, and the first passive house premium commercial building in the UK, or even all of the UK, not just commercial. And there's myself and Tomas and my contact details. So please don't hesitate to get in touch. And that's me for tonight. So I'll hand back to Simon or Tomas. I can't remember the logistics, and we'll open the floor, I think, for a few questions.
Thanks very much, Barry. Thanks for sharing us the journey of that building, and really exciting to have a building of that stature in the passive house world on our doorstep, and really look forward to coming and seeing it whenever we can. So I've got a couple of questions which I'll put through to you, and we'll I think you said we might pull Tomas into that as well as the certifier, just to help with some of the answers. First question from Kevin Holmes was if you could just kind of reiterate what the structure of the building was.
Oh yeah, okay. So the building is primarily steel frame, and again you can see there behind us there's quite a lot of glazing to the south side, but the envelope to the other orientations is primarily a timber frame, inner skin, of course with quite a good U value. I think I said of 0.13 earlier, and again it's got a brick outer face then as well, facing the car park and the other two end elevations. So hopefully that answers that.
Okay, the next question is from Sophia Barker. So there's actually 4 parts to this question, so we'll maybe just go through them one by one, Barry. So the first part was a comment really on glazing proportions. So you've got quite a lot of south-facing glazing, and Sophia wanted to know just how the summer comfort is being managed.
Okay, well, I did allude to it during the presentation there. The overheating is assessed at just over 2%, so that is a really low figure. And again, I think I attended a masterclass with the UK Passive House Trust in the past as well, and it's them that have been heading up leading out on the overheating best practice, and they really talk about doing a stress test and having it below the 5%. So that's one of the ways in which we've combated it. You can see the significant amount of brise soleil there as well. We've shading with the trees. We also then have, like I spoke about, the subsoil heat exchange, which in the summertime will provide a bit of cooling as well. And we also have the atrium, which is a passive stack effect and allows us to implement night cooling as well, or night purging. I think that's part of the strategy as well. So maybe that's that answer. I don't know if Tomas wants to jump in with anything additional there, but that might only be the first part of the question, I think.
Yeah, I mean, we were there, Simon, at the presentation of the certificate, and it was one of the warmest sunny days that we had this year, and we were all a bit curious, to be honest. What is it going to be like? It's one thing to have a PHPP model, it's another thing to walk into a building, and it was just wonderful. There's a vast area of glazing there, but there's a very extensive brise soleil as well, and you've a lovely view over Enniskillen town. You're elevated over the Lough Erne system, and I think the architects honestly just did such a wonderful job. So it is heavily glazed, absolutely it is, but actually the shading, the external brise soleil shading structure is so well designed that it provides a really comfortable indoor environment. So I think, that was a really great to experience that at first hand.
Another part to Sophia's question was, were there any interesting finds on how to reduce the unregulated loads? So again, from our own experience in this type of building, you kind of, you've got to try and account for all of those activities that are going on, and some of those can be quite difficult to deal with. So just wondering what the experience was with regards to that.
Yeah, there is one thing that jumps out at me straight away was for the catering school, in terms of reducing primary energy for electricity and fuel as well. There was You know, we had to embrace the induction cooking as opposed to gas, and that was one of the things I remember coming through on it. That's just one thought. Tomas, you're probably closer to that than me.
Yeah, I mean, when we were looking at the equipment list for this building, I'd never seen anything like it. It was like a ginormous spreadsheet, you know, like 500 laptops, you know, 100 hair dryers, you know, there was lists of equipment that you would never ever imagine seeing in a passive house building, and everything was itemized and factored in, including students, you know, having 4 chargers each for their phones and this kind of thing. So it'll be interesting to see, you know, after the first year of occupation, what the electricity, you know, the primary energy consumption actually comes in at. But again, hats off to the engineers involved in the project who did the initial modeling. I mean, it was just extremely impressive. I don't think they left anything to chance, quite frankly. So it'll be interesting to see how that comes in. On that.
Okay, and I think one final question just before we go to the breakout rooms. How did the team approach the air tightness testing throughout the build? So obviously one of the largest passive house buildings in Ireland, I'm sure, and we're all used to testing houses, which is relatively simple at the end of the day. But what was the approach taken? Did you have to sequence it, or did you undertake it as a whole?
I could go in there, Barry, if I may, briefly. So first of all, I think it's interesting to say that for everybody on this project, it was pretty much their first passive house project. And we've seen that across the world, the same with the Cornell Tower in Manhattan. So you shouldn't be afraid of passive house. You know, the contractor had never done passive before, and now they've done the largest passive house premium education building. So we ran some training, actually, some toolbox talks. I think there was about 50 or 60 people on the site at the day when we did air tightness training. And then the contractor, Tracy Brothers, they actually isolated a sliver of that atrium, Simon. So they effectively sort of created a sort of a temporary partition around a kind of an awkward part of the building. And they felt basically, right, if we can get the New York song, if we can do it here, we can do it anywhere. And I think that gave them the confidence then to progress. And it was also interesting, I mean, it's essentially a stick frame building. It was a timber frame project built on site on one side, you know, and curtain wall on the other side. And so I would say quite a simple, if I say unsophisticated, I don't mean that in a derogatory way. And yet look at the air tightness level they got. And I think hats off to them for that. So steady as you go, lots of training, good materials, good details, and then, you know, partial testing halfway along just to make sure we're on the right track.
Okay, well, thanks very much, Barry, and thanks for Tomas to your input on the answers. I think if we switch now to the breakout room, so everybody please hang on. It's a good chance, 5 minutes to have a quick chat, reflect on what we've heard, and then we'll come back together just to close out. So over to you, Tomas.
Thanks. Yeah, and how this works, guys, you're going to get a little signal on your laptop or your phone, asked to join a breakout room. We've only got 2 or 3 people per room, so you can have a nice chat on that. And we would ask you to hang on for that, because there's a chance to maybe chinwag with people who are doing passive house. You might get some nice experiences there. So we'll run this for a few minutes. Good evening, everybody. How are you all doing? You can unmute yourself now. Welcome back, everybody. Hopefully that was, hopefully you had some interesting discussions with everybody that you were with there. So I would like to, I suppose, to move towards closing this evening's session. We take pride in trying to run this like a good train station, everything running on time. I'd really love to thank Barry tonight for a most enlightening presentation. This has been the fourth in a series of evening summer seminars that we've run. We intend to continue this series in the autumn time. So please check in again with us after the summer break. And one item of note maybe for the autumn would be the International Passive House Conference run by the Passive House Institute. I'm not sure where we will be on the COVID pandemic path. We seem to be going through a bit of a speed wobble at the moment on that, but hopefully all being well, you could physically attend or certainly virtually attend the International Passive House Conference. So that remains, that's basically all we've got time for this evening. Thanks a million to Simon and to Barry and to all of you for giving up an hour of your evening this evening. We hope you enjoyed it, and we'll see you all again soon. Thank you so much, and keep well and safe well. Bye-bye now.
Bye.
Cheers, everyone. Bye.
Thank you.